Okay, in this section what we're going to be doing is we're going to add some tangent velocity to it, so that basically these rings, as they are created, they start spinning around. Yeah? And also we're going to start preparing our particles so that we can start using them inside of SOPs with our volumes, and so basically we'll be adding some color, some opacity and some scale. Alright, but first let's add this tangent velocity. So the way to go about doing that is again add another FOP pop, so FOP pop, and I'm going to name it tangent, tan velocity, tan veloc. Okay, let's jump inside there. There's my output, there's my global variables. What I want to do, since my my new split particles have normals on them, so you can kind of see those normals, and at the same time they've got another normal as well, which is the velocity, the outwards velocity. So as you can see, as they grow, you can kind of imagine this velocity vector sort of that way, and at the same time there's the other inherited parent velocity vector sort of over there. And what we want to do is use another cross product, and get a resultant vector which is sort of, perpendicular to one of these edges. So what that will cause is either a resultant vector in this direction, so say so counterclockwise or clockwise, and that will basically depend on the order of the input vector. So if the cross product first would take in the normal and then would take in the vector, then it will basically start to rotate one direction and otherwise another direction. I mean, we'll see this. So let's just get our normal vector, and we'll get our velocity vector, and we're going to cross them together. So let's add a cross product to it. So there's my normal, plug it into input 1, there's my velocity, plug it into input 2, and we could already say, like, if we add this to the existing velocity, so add, add this velocity and the resultant tangent velocity. So this you can see as a tangent velocity, and if we add a sum to our velocity, the resultant velocity, and if we play this should already start to give some results. Let's have a look. Is it rotating? No, not yet. What we need to do as well is make sure that this is normalized, because it might just be really small. So what we can do is add a normalize operator to this, normalize, and also let's give it a little bit more control. So before we go into this add, let's add a multiplier to it. So we could say we make it stronger or less strong. So if you say a multiplier, and I want to multiply with a parameter, this can be a floating point, that's fine. So let's call this tan mult, so tangent multiplier, tangent velocity multiplier, and multiplier. Let's just copy this on top of that, and I do want it to be visible because I'll be using it to control later on. Okay, so let's have a look. Let's go up and make sure our display flag needs to be set on this guy, and also let's put this by default on 1. And let's have a look what happens now. So as you can see, they start to spin around. So it might be a little bit too fast, so I'll just go through it step by step, so you can kind of start seeing there. Yeah, that, I hope you can see it. So maybe look at this 1516, and then now the 1516 is over there. Now it's over there. So it's kind of rotating counterclockwise. You can kind of see it's gonna go this way. Yeah, there's a 60 now. So it's a bit hard to see. You kind of have to look at the point numbers, but it is rotating. It is actually adding this this tangent velocity to it, which is fine. One nice little touch that you could add to this is say that you want it to rotate less, so the tangent velocity should become less over the life of the particle. Yeah, so that would be kind of nice. So this multiplier can go from 0 to 1 or 2 or whatever kind of value. It'll just, you know, increase this value. So what we could do is, if we do $life, then in the beginning there will be no tangent value, and in the end there will be a lot. But that's actually not what I want. I want the opposite of this. So in order to sort of get the complement, I'm going to say 1 minus $life. And this will basically give me a value that goes from 1 to 0 over the life of the particle. So as the particle ages, it's going to spin less. And let's have a look at that. Also, I'm going to activate my sort of real-time toggle, so it's not playing as fast. And there we go, and you can kind of see them spinning, sort of, hopefully. Yeah, so they're spinning around. Yeah. Okay, so that's good. The next thing that I want to add is a little bit of color, an alpha, and then a scale. So first of all, let's add some color. So in the color, this is fine. I'm going to change this to a ramp. And again, the most important thing there is the lookup. The lookup will be using $life. So if normalized value, the particle's age that goes from 0 to 1. Okay, let's give it just some color. So say something light in the beginning. Something like this. Then something yellowish. Yeah, it's fine. Something darker now, so a bit more orangey, brownish. And then let's start to head down, really, the dark, sort of dark brown. A little less saturated. And really dark now, so something like that. Yeah, it's almost black. So we got this kind of nice smoky-ish, you know, sort of color going on. So if you look at this, we can kind of see, bam. Also, I mean, it's applied to everything, the initial particle as well, but we won't be using this anyway. That's fine. So you can kind of see now the colors are being applied over there, and it's going dark. So in the beginning, it's light and it goes dark. Okay, let's add another color. I just like to separate them because I can identify which one is for the color and which one is for the alpha. So I'll be using this one on the alpha. Make sure to change tabs to the alpha, go to the ramp, and what I want them to do is basically, again, over the life of the particles, I want them to fade in and fade out. So I'm just going to add a little value over there. So the first value is going to have to be a black alpha. So change the alpha to 0 there. You can kind of see on the small ramp on the bottom, this value is 0. This guy's value is going to 1, so that's fine. So it's kind of leaving it some time to ramp up. Then I want to have it visible over this entire range, so an alpha of 1 over there is fine. And then slowly let it go back down and make sure that at the very end it's both to 0. So this guy's to 0 and this guy as well. So this will kind of fade it off nicely. Okay. So what this will do, should do, is sort of fade it off as they start disappearing. But you really will start to see this above with the volume once we start implementing this. Okay, so one more thing is I'm going to add a property to this, and that will be the scale. So let's add a property. The kind of property I want is under MISC, and I want a uniform scale. Yeah. And instead of p-scale, I'm going to type in a little expression which will be using the fit function. So in the same way that we've kind of used the fit function before in VOPs, I'm now kind of using it. So you can kind of see it's got 5 arguments input. So the first will be the value, that will be $life, which goes from 0 to 1, which I know because it's normalized. I want it to start at, say, 0.2, so it already starts with a little bit of radius. It doesn't come from 0 and just go to 1, so a minor adjustment really. Okay, so that'll be added there. So I'm just going to say property, and that'll be sort of p-scale. Yeah. And then I'm going to add a null and make sure that we're going out to, so say out to subs. Yep. So that's good. I'm thinking I will need to add one more group to this, because when I'll do my copying, then I want to use all of these except for that guy. Yeah, I don't want that guy. So the way to go about doing that, maybe I'll do that a little bit higher up, sort of after my split. That would be a nice space to add this before I start adding all these other attributes. What I'll do is I'll just make a new group, yeah? And this group I'm going to call group preserve split. So this group will basically catch all the particles that are currently being split or that have ever been split off. So the way to go about doing that is just say, okay, I'm gonna name it preserve split underscore grp. My generator in this case will be, I'll use a generator to group them, and the one that I want is my split one. Yeah? So all the particles that have ever come from split one will now be stored into split, preserve. So I need to turn the preserve on, so you can kind of see the difference. If I rewind this once more, and I'm gonna turn that off, go all the way down, and let's rewind this, play this. So bam, you can kind of see over there there's only one. Up. So at the moment I'm at frame 60, so there will be particles in my split group, 29 particles in my split group, and then the total sort of number of particles that have ever been split off, 86 particles, yeah, in the preserve split group. And that's good because I'll be using that to sort of copy my spheres on. So let's go up again, because as you can see over there at the moment there's this huge sphere, and that's from the parent particle, which is one that I don't really want to use. So if I just take a look at my particles, they're all coming there, yeah, so that's good, and they'll be rotating as well. So let's have a look at this. First of all, the template group that I want to use is that preserve split group. So if I put that preserve split group in there, you can already see the first particle does not inherit these attributes. Okay, so they're starting to rotate and they're doing their thing, and that's all fine. So some of them have a different lifespan. Since we're scaling them differently, you can kind of see how that is affecting, over there. Okay, so what I want to do is I want to start stamping. So let's start stamping the inputs. The first thing that I want to do is use copy num, and also I want to use my attributes that come from my template. So yeah, okay, immediately if I disable my grid, immediately you can kind of see a bit the color and the opacity will be trying like this. So the opacity will be trying to update. Okay, so that's fine. One thing that I do want to turn off is transform using template point attributes, because I don't really want them to start rotating along the velocity normal or stuff like that. So I'm going to turn that off. Yeah. So I'm going to manually add that point scale in there as well. So first of all, copy num. I'm going to use $id. I'm not going to use $pt, not the point number, because my point number of my particles is continuously changing. As you can see, as particles are born or die, yeah, you can kind of see this point number. Now this, the same point was 14, it's now become 13. It's gonna change some more. Now it's become 10. So in order to avoid that, we use $id, which is a value which is unique to every particle. Yeah. Okay, the other value that I want is point scale, so I'm just going to use pt scale, and the value I want to use for that is p scale. This is all coming from my pop network. So again, this is coming from these last three nodes. So we've got the color, the alpha, and the p scale over there that's been added. And I'm now referencing them inside of my stamping operation. Make sure to turn on stamp inputs. And the final one I want to use is my alpha. Yeah? So I'll be using that inside of my volume. So pt alpha. And the way to go about referencing that is by saying the alpha color, so $CA. Yeah? Okay. Boom. So that's quite dense. I'm going to use sphere for now. The frequency is fine. The reason why I want to use this high frequency, if I just visualize this and bring up the wireframe, is I'm going to turn this into a volume, right? So I'm going to add a volume underneath this. The way to go about doing that is adding an ISO offset, yeah? And if I look at this, as you can already see, it's kind of converted this into an isosurface, but I don't want to use an isosurface, I want to use a fog volume, yeah? A fog volume as such. Now the resolution of my fog will be important. This will kind of give me the amount of detail that I've got. So let's have a look at that. Say I want to, just as a start, sort of use a 20 by 20. So this will give me sort of a finer definition of my volume. Okay, one of the main things that I want to do as well is I'm going to start adding noise to this. So I'm going to apply a little offset to this. So something small, so something like I don't know, minus 0.2. So it's a bit, I've got this kind of room to play with if the noise is applied. How do I apply noise to this? I'm going to apply a volume mix. A volume mix is almost in a way like, well, I see it a bit like a point sop, but then for volumes, because it allows me to mix stuff together, and it allows me access to sort of a user parameter. Inside of that user parameter, I've got access to every individual volume, so every individual voxel. So this like, a cubic grid, and this represents, like the first sort of value over there on that little cube. Alright, so what I can do is start adding different manipulations to this. So I'm going to add a spherical noise, so S noise. This will return a vector. And what I can do is use $x, $y, and $z. And as soon as I did that, you can kind of see, as I type that in, that I've got sort of my my noise in there. But nothing is moving and nothing is random, so I'm going to add some parameters and randomize that. But I want to start doing render tests at this point as well, so I'm going to start laying down a camera and some lights. Okay, so I'll do that in the next session, so let's save this again.